Alright, so let's keep working on the area of regular polygons. This was actually one of the homework problems from the first portion. I had a few questions, so let's take a look how to do these. This was number 18. They give us a figure here, and we need to find the area. Alright, and the thought here is pretty much to find the area of a regular polygon, we are going to think of the figure as a bunch of triangles, like that. Okay, and you can see there are if I'm counting the big triangles, 1, 2, 3, 4, 5, and 6. And that's going to be the same as the number of sides, right? So that's how many triangles you'll have. So we'll just say n equals 6. That's the number of sides. That's how many triangles there are. And what I want to do is find the area of one of the triangles. Okay, namely, let's start out with this one, because they're all the same, but that's the one where we know some of the measurements. And the way I'm going to do that is by using the given information. Okay, so let's just kind of focus on this half of the triangle, and let's kind of enlarge it here, see what they gave us. Okay, so this was the side that was 20. The apothem here was the height. Okay, it's the distance, remember, from the center to the edge of the polygon. So I'm actually going to find the area of this shaded triangle here. And then what I'll have to do is just times that by 2 to give us the full yellow triangle. And then we will times that by 6 because there are 6 total triangles. Okay, so what we're going to need to do to find the area of a triangle, it's 1/2 base times height. So in this case, we know the height, okay, is the 10 root 3. The base is what's going to be down here. We can call that whatever you want, b. And then the 20 is not going to be part of our area, but we're going to use that to find the base, okay? And since we know it's a right triangle and we have 2 of the 3 sides, we can use Pythagorean Theorem to find b first. Alright, so Pythagorean would tell us that b squared plus the other leg is 10 root 3 squared must equal 20 squared. Okay, b squared, so 10 root 3 times itself, just do a little scratch work over here, 10 root 3 times 10 root 3, and of course you can do a calculator, but just to see what it's really doing, the 10 times 10 is 100, right? The root 3 times root 3 is root 9, okay, which is 3, so this is really going to be 300, right? 100 times 3, okay, or again, feel free, calculator can always handle that. 20 squared is 400. So we can subtract 300 from both sides. B squared is going to equal 100. And that means that B down here, okay, which is just this half of the base down there, must be 10. Okay, so what that tells me then is that each of these triangles, for example, triangle G, E, D, okay, from E to D is 20, and we know the height was given originally, that's the 10 root 3. Okay, so the area of that triangle is always 1/2 base times height. So the area of each triangle is 1/2, okay, times the base, which was 20, times the height, which is 10 root 3. Okay, so if we calculate that out, 1/2 times 10 times 10 square roots of 3, the area of each triangle is around 86.6 square units, whatever the unit might be. Okay, and then so the total area, since this is a 6-sided, right, it's a hexagon, the total area is just going to be that number times 6, because there were 6 triangles that make it up. So if we multiply by 6, we get an approximate answer of around 519.6. Okay, so just think of it as a bunch of little triangles. You can use Pythagorean Theorem if you know 2 of the 3 sides, and then you can find the area of each triangle and then kind of multiply that. Okay, let's do one more example in this section where we're going to do a little different thought process. Or get a little more creative. So this one, a regular octagon, is inscribed in a circle as we see the figure on the left with a radius of 4 units. Okay, and we want to find the area and perimeter of the octagon. So what I did, I took one of the triangles, you can see the yellow chunk there, a little piece of the pie, and enlarged it over there on the right so we can see what's going on. Okay, so this one now, we don't know two of the three sides, right? We only know one. Okay, or if I mean as the whole triangle, we know the two diagonal sides are 4, but it's not a right triangle then. So we can't use Pythagorean with 4 and 4, but if I think of it as a right triangle, right, either side, all we know is one side, right? We know the hypotenuse, but we don't know either of the other two sides. So here's what we got to do. We need to figure out what these angle measures are. Okay, and then we're going to use some trig, SOHCAHTOA, coming back again. So, all right, think about this. In this figure here, I don't know if you guys have ever seen Trivial Pursuit. I keep thinking of the game board here. You put like pieces of the pie in as you move around or whatever. Probably before your time. Anyways, so we have 1, 2, 3, 4, 5, 6, 7. Did I miss one? 1, 2, 3, 4. Yeah, it should be 8, right? Octagon. Okay, so we have 8 sides, and then so therefore there are 8 central angles. Okay, since the figure is regular, all this stuff works, all these formulas and process only work if it's a regular figure, meaning all the angles and all the sides are equal. Okay, so since it's regular, I know that each interior angle needs to be the same. And there are 8 of them, okay, and the full circle is 360. So 360 divided by 8 is 45 degrees. Okay, so that means that each of these angles, okay, and in this picture would be that entire angle is 45 degrees. Okay, in our right triangle though, there were 2, right? So this is only half of that. So I know that this little angle here is half of 45, or 22.5 degrees. Okay, so we're going to use that. Okay, let's see if we can even draw on one more figure here. Here's what we're doing. This angle is 22.5. The hypotenuse over here is 4. Okay, what we're going to need, we need both sides here, right? We're going to need this. This is the apothem here. It's going to be in the height of the triangle. And then we're going to need this bottom part. That's going to become part of the base of the triangle. And that's going to help us find the area and the perimeter. Alright, so I'm just going to label these A and B. A for apothem, B for base. It's part of the base, right? Okay, you can call them X, Y, call them whatever you want. So let's think about what we have here. So we have a triangle. I know an angle, okay? I know, using trig ratios, that the sine, gotta get back to the marker here, the sine of 22.5 degrees, right? Sine is opposite over hypotenuse, right? So the 4 is clearly the hypotenuse. From that 22.5, the B is the opposite side. And the hypotenuse is 4. Okay, so what I'm going to do on my calculator, make sure we're in degree mode. Okay, I'm going to solve for B. I'm just going to multiply both sides by 4. So 4 times the sine of 22.5. Okay, I'm going to multiply both sides by 4. Okay, so B will end up equaling, I'm getting about 1.53. Okay, so that's this length down here, 1.53. Okay, similarly, I can find A. Once you find that second side, though, actually, once you found B, we could use Pythagorean Theorem now, if you really wanted to. I'm just going to use the trig because I think it's a little quicker, but of course that is an option. So now to find A, though, again, A is the adjacent side, so that means that the cosine, right, cosine is adjacent over hypotenuse. So the cosine of the angle must equal the adjacent side A over the hypotenuse 4. I'm going to do the same thing, multiply both sides by 4 to get a value for A of about I'm going to round it to 3.7 because it's 3.695. So let's just say that's 3.7. Okay, so let's see what we got. Let's start labeling some things here. So in the picture, this bottom length was 1.53, right? So that means the entire base of the triangle, if I double that, is around 3.06. Okay, so each side of this figure of the octagon, right, is approximately 3.06. And I need that because this question, they want the perimeter of the octagon too. The perimeter of the octagon is just the side lengths added up. We have 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. So the perimeter is just that 3.06 times 8. Okay, so let's get that one out of the way. The perimeter take the 3.06, times it by 8. Okay, that's going to get us a perimeter of about 24.48, whatever unit we're in. Okay, so the perimeter is done. Okay, and then to finish this up with area, just like we did previously, we're going to find the area of one triangle and we're going to times it by 8. Okay, so the area of the triangle, and when I say the triangle, I mean the entire yellow triangle, right, is 1/2 base times height. Okay, 1/2 base times height. Okay, we found the base. The base of the triangle is one of the sides of the octagon, right? 3.06. Okay, let me change color so it shows up here. And the height was what we found, the apothem, right? This 3.7 here was the height of the triangle right here, right? Okay. So the area of each triangle, 0.5 times 3.06 times 3.7. So the area of each triangle is about 5.661. So that's the area of each triangle. So then our total final area, again, since this thing was an octagon, total area will just be that number times 8. So the total area, we'll take the 5.661, multiply by 8, because there were 8 triangles. Total area is just over 45, around 45.288. Okay, so same concept. It's generally going to involve using a sine and a cosine, one of each. You know, one will find you the base, one will find you the apothem, which ends up being the height. But depending on what the picture is given, what information you're given, you might have to, you know, use one or the other, but most likely both. Okay, so we will practice those a little bit, and hope that helps. All right.